Very warm to all. Please join in to the session. Today we are going to hello everybody. Is it okay? Audible? Clear? Hello.
Yes, good morning. I hope I'm audible.
Good morning, sir. Yes, you are audible.
Yes, yes. Thank you, Dr. Sandeep.
Good morning, sir.
Hi, good morning.
How are you, sir?
So, yeah, good, good, good. Dr. Singham also joining today?
Image and sir.
Yeah, okay, okay, okay.
Okay.
Yeah, hello, Dr. Nagaraju. Good morning. I think you have to unmute yourself.
Yeah, very good morning. Very good morning, sir. Very good morning, sir. Warm welcome to the today's session, sir.
Thank you.
We feel very happy to invite you. You readily accepted, sir, for the invitation to give an advanced advanced taxonomy, especially APG system of classification. That's very much needed in the present generation. We all should know, all the students and faculty. That is very much needed for the all young generation, young budding scientists, sir. We feel for sir. Chowdhary sir is from Agarkar Research Institute, Pune. Has done a lot of work on the taxonomy and he has published a lot of papers and so many projects he is now running as a very eminent person in the scientific field. Sir is from Scientist E. Agarkar Research Institute, a He has work PhD research work from BSI Botanical Survey of India. Sir, please welcome, sir. Please give your valuable talk,
Thank
sir. Thank you, sir. Please, sir, welcome, sir. Please, sir.
thank you. Thank you. Well, good morning to everyone. And I will share my presentation first. Please confirm it if it's visible to everyone. Dr. Sandeep, could you please confirm it's
Yes,
visible?
yes, it is
Yeah,
visible.
yeah.
Yes, very visible.
Okay, okay. So I'll start my today's talk, which is about APG system of plant classification. And as we already know that APG is nowadays the most advanced system of classification in angiosperms. But before that, I would like to ask you, usually, I don't know how many students are sitting there, but usually I ask the student like about their idea of plant classification system. Since it is not an interactive session, I am always more happy to interact with the students. And then the second question which I asked to the student about their favorite system of classification. And the answer which I mostly get is the Bentham and Hooker system of classification because of its easy to use in the field. And then when I ask them that what are the difficulties when they face when they study APG system of classification, what kind of difficulties they face. So the first answer comes from them is like when they see a phylogenetic tree, it becomes very difficult to understand, to interpret how to read the tree, and it looks very complicated. So most of the students they answer like that. Today, I would like to make it sure that this confusion will go away, and you will understand APG system of classification in a much better way. Before going ahead, I would like to quote Hasse et al.'s paper, which was published as a per pollen terminology. Here he has mentioned that nature itself neither needs categories nor has knowledge of them. Right. So it's not the nature which actually divides it into multiple families, angiosperm, gymnosperm. It is categories, they are always artificial. We make them. We make them individually, and it always divide individually by individual convention or some single person will do or some people will come to good decide to classify them like that. And humans and define them in botanical terms. We use facility to make to this problem to classify something. No, my classification is more stable or your classification is more stable. We confuse always in terms of like we take them as well like a it's a dynamic system, and it depends on so many factors which we are going to learn today. First thing, what are the prerequisites for a classification system? To have a good classification system, what are the prerequisites? What are the things which required? First thing, it must be stable and universal. It should be there for a long time and should be universally accepted throughout the globe. And also, it must enhance communication of knowledge by helping us to relate things. We should be able to relate things by just looking at the classification system easily. And also, it should talk about the relationship of one group to the other group. So we already know how it has evolved. Before this molecular arrived, we had this natural system of classification, artificial, phylogenetic system classification, which was based on morphology only. And then the molecular era came where most of them they were defined based on plastic markers or the nuclear markers. Now we are into a kind of era where we are taking the nuclear region or plastic region, but we are considering transcriptome data, other data sets to classify their life forms or organisms. Before we go ahead, we must understand how to classify for your convenience. We have kind of written what we say, what we classify, or to understand this, the portion which you see is called root, and then you have internodes, we have branches which are terminal branches, and overall the structure is called topology. Okay. understand. And each node actually, this node you see, these node actually represent the taxon which has given through these different group one, group two, group three, like that. And before we go ahead, three terms are there which help us to understand the APG system of operation. But the first thing is called monophyly. So to make it clear, I have written valid clade is monophyletic, which consists of the ancestor species. Here in this one, you can see that species E, F, G, H, they have a common ancestor from here in the green line I have shown. And for species A, B, C, D, they have one common ancestor here. If you can see my arrows here, so they have descended from a single node, and that's why it is called monophyletic group. So EFGH would be called, and another group ABCD would be called other monophyletic group here. It's a hypothetical grouping, not real. In other words, you can say it's a taxonomic group defined by possession of one or more synaptic features. Synapomorphy, it's kind of apomorphy, a director with being shared. So EFGH, these four species, they share some. ABCD, they share some particular common character, which was given rise by this particular node. And another one is called polyphyly. Here, what is poly means multiple. So polyphyletic clade includes many species that lack a single ancestor. You see that C, D, E, F, they are morphologically similar species, but they don't have a common ancestor. Here in this case, what is common ancestor would be this particular node, ABCD is this particular node, ABCD is this node, common node, and E and F, you have another common node, which could be called as the ancestor species. So here you can see for CDEF, if you consider, there are two different ancestors. Okay, and if you have any question, just type in your this message box. Though I'm not able to see them here. And then another word is called polyphyly. When you have species but no common ancestor. And a very good example of this polyphyly is the presence of wings in bat and birds. Though they are not commonly, they are not came from common origin. They are sharing the same character. They are phylogenetically far apart, but you have already. So I'm not able to see if you are typing something. Please let me know this by turning on your microphone. Okay. If you have any question in the middle, because I cannot see your questions here. So polyphyly, the three things are there: monophyly, polyphyly, and then you have paraphyly. Sorry, paraphyly is the example. I just missed it. That presence of wings in bat and birds are another example of paraphyly. Where suddenly, if you see presence of some character which is there in some species, the same character is present. Like it's a clear consist of ancestral species and some biological species. They have suddenly A or B, these two species, they start showing different character, which was actually character of some other group. So such character or such grouping is called paraphyly. So there are three terms which you must understand. The first thing, monophyly, when you have single ancestor, polyphyly, multiple ancestors, and paraphyly, it is a kind of paraphyletic where you find in a multiphyletic group, you find something, some particular character, actually not the feature of a particular group, is suddenly appearing in it. Okay, and there is some event to it. We will understand in a much better way. I'm going to give you some more examples. Now, before going ahead, I have shown you one Here you have another group, and then you have some small group. You can consider this overall as a morphologic group, or within this you can find two subclades are there. So this is very important to understand for understanding APG system of classification. Have you got some clarity, Dr. Sandeep, or other students?
Yes, sir.
Okay, so overall, so monopoly, it's all about like how they are grouped together. So they have given right there, if you consider one group like one species, suppose species one, two, three, four. So they have one common ancestor. So this particular monophyletic group had one common ancestor which was there present on this node. Same way, if you consider this node, it will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11 species or 11 group of life forms here, which has this particular node has given rise to those species. So for this one, you have something coming out from this node. Okay, is it clear, Dr. Sandeep?
Yes, sir.
Same way now you understand this. So this is nothing but what I'm showing you a APG system of classifications tree. Can you see this overall on this node? I have written angiosperm. It is written. So this is all angiosperm how they're related to each other. You see, this is a big monophyletic group. In this monophyletic group, you have several small groups. So here, as I'm showing you magnolids, they are forming one particular monophyletic grouping. So magnolids had one particular common ancestor here. Same way for commelinids, same way for fabids, malvids. We are going to learn it in a much better way in coming slides. So we move ahead. So how this particular APG system of classification was conceptualized, we already know about Bentham and Hooker's system of classification, which was more popular in UK and the Indian subcontinents. Same way in Europe, Engler and Prandtl system was more accepted, and Cronquist system was more acceptable in USA, and Taxonomy system of classification was more accepted in Soviet Union. So there was no consensus among the people. So some of them they say, no, this is the most valid system of classification. There is a kind of conflict among them, or there is some envy. Understanding was not particular. Though there is no consensus, and also there were several deficiencies. Like all these system of classification, they're mostly based on morphological characters, and there is no concept of monophyly in those system of classification. So this fellow, and also this particular thing which we talked about the presence of wings in birds and bat. So the same enigma, none of the classification system had addressed this problem of convergent evolution. As you can see here, two cactus-like thing. One of them is a cactus, another one is a Euphorbiaceae member. Right. So based on morphology, sometimes it becomes very confusing. But if you just take out DNA out of them, you will understand one of them belong to Cactaceae family, another one belong to Euphorbiaceae family. So this is called convergent evolution, and this particular thing was never addressed in the previous classification system. So this fellow called Keir Bremer and is a husband of the famous taxonomist called Brigitta Bremer. And this particular Bremer as one drop in 1978, long back, they took the first attempt towards the cladistic classification, and they suggested that angiosperm should be treated as subclass Magnolidae of as a subclass. And then monocots and dicots should not be recognized. They should not be recognized because this will make the group phyletic. And then angiosperm should be directly divided among purpose, not like this of what they are seen in Bentham and Hooker system classification. Based on his opinion, and many top-notch scientists throughout the from all across the world, like the wife also Bremer, Keir Bremer, and And then if you see this, APG 1 was launched long back. And then APG 2 appeared 2003, APG 2009, and then what we presently have is APG 4, which was proposed into 2016. So for the students to make actually the first second system was launched after 5 years, and 6 years this APG 3 was launched, and after 7 years APG 4 launched. So statistically, Dr. Sandeep is asking APG 5
Yes,
already has
yes,
been drafted APG 5. Recently, I attended the International Botanical Congress where they informed us that probably in October APG 5 will appear. So that's why we are asking we just have to it's whatever leaders had proposed the system of orders and families has to be there. There should not be variation. And these all groups should be multi-modality. So the idea of 1 5 was introduced. And the upward step. So what was this broad approach? To understand in a much better way when you what was this broad approach? Okay, but like basically you understand broad approach is what? So suppose some family is showing some characters which could be given an order rank. So they're saying broadly we have to think and we have that as an order instead of putting this as a family. So if it has certain deviation, certain more characters than the family, but above or parallel to the family, the term pigs. You do like okay, after this above the order you have that has been reduced above proposed. And many of the people have kind of misconception that it was solely based on plastidial markers. But no, it was also based on nuclear markers. So always you keep that in mind. Many people they say that it was solely based on plastidial system of plastidial marker, plastid markers. But no, they had also considered nuclear marker like this 18SR ribosomal DNA. It is a region from the nucleus. So this was also included there, but the sampling was less. That's why many people they consider this as okay, since RBCL and ATPB they are in the chloroplast. Consider that this was solely based on plastidial or the chloroplast. So and then they divided that as a different clade. Instead, this order level of above the level of order clades term was used, and eudicots and monocots were not given a formal rank on the grounds it is not yet clear that they should be common. If you see this tree clearly, if you see this, many of the dicots they did not form a particular clade. Rather, their ancestry was unresolved. I'm going to show it more clearly in coming slides. And then many of the families they remained unplaced at that time in 1998 because data was not available. So almost there are still 25 families they remain in uncerticidus we call. So they remain treated in this and because their ancestry was not resolved during that time. And then the concept of bracketed taxa was introduced. This is very important for you to understand what is this bracketed taxa concept. So what was this? Suppose the slobel system, which was kind of under this campanula. So they place this under the bracket saying if you want to treat this as the lobeliaceae that is also fine, or if you want to treat as campanulaceae that is also okay. So this was the concept of bracketed taxa. So in the bracket, if you can see this lobeliaceae was there. So it means if you are free to use this as an independent family like lobeliaceae, or if you want to treat this campanulaceae. So this was also widely criticized because if we are not still sure of their status, why we have introduced this bracketed taxa concept. But it was there. And the major outcome was that the disappearance of the traditional division of monocots and dicots. Because many of the dicots, they were kind of nested within this, their dicot was divided in two different groups, and between these monocots suddenly appeared based on this data. And this data, as you can see, it was based on three markers, RBCL ATPB from plastids, from chloroplast, and 18S ribosomal DNA from the nuclear region, and the monocots were recognized as a clade, but the dicots were not. Dicots were not recognized as a monophyletic group. Rather, they appeared as polyphyletic grouping. That's why they proposed this different system called different grouping called eudicots. So eudicots, they were a kind of common clade, single monophyletic grouping. That's why they proposed eudicot kind of thing. Okay, and they were considered the basal dicots. As you can see, this ceratophyllins and laurels, magnolials, piperils, they separated out. And then in between, you can see monocots are coming, corals, alismetals, lilials, commelinals. They all came in between. They nested within dicots. That's why this particular dicot, they did not form a single monophyletic group. That's why they given a term called eudicots here. And here you can see the monocots. It appeared like this. So they given terms eudicots. And in eudicot also, if you see there are two different big monophyletic groupings are there. Here, can you see Dr. Sandeep? Here, two different big groups are there. And these
Yes, sir.
two different monophyletic groups, here they named as big group called rosids. Another big group they named as asterids. So in eudicots, you have two major monophyletic groups inside two small groups, and that were named as rosids and asterids. Moving further, this was little bit unusual APG one system because it was based mostly on this molecular data along with some data. But one good thing was this: all the eudicot region, this eudicot, they had a common morphological feature. And what was that common morphological feature? They were combined with the pollen character. All of them, they had tricolpid type of pollen. In all monocots, they had a monocolpid type of pollen. Those certain variations are there if you go down further, but in majority, they were divided like that. So all monocots with monocolpate type of pollen and all eudicot with tricolpate type of pollen. But still, there are a lot of fighting among people because this bracketed taxa concept was introduced. People were started all the taxonomies they started arguing, fighting among this. Like small circle family under Malvaceae they put because it nested within Malvaceae. It formed a monophyletic group. So there was a fighting and there was a controversy. So they also realized this. The system was controversial in decision at the family level, splitting a number of long established families and submerging a number of other families. You already know about Stepedici was also merged within Apocynaceae, which created a lot of problems. Many people they argued no, Asclepiadaceae stands as a distinct family, but because of this data, it was since it was forming a monophyletic group inside Apocynaceae, they had no choice but to propose this as a distinct clade. Okay, but there is still controversy at that time. So it was again unusual to not using botanical ranks. As if you are simply using the term clade. So people also they did not appreciate it, and there's a lot of confusion. Higher groups were defined only clades with names such as monocots, eudicot clade, monocot clade, eudicot, rosids clade, asteroid clades. So this was also not appreciated by the traditional taxonomists. But despite all of the things, they had accumulation of more and more data. So they upgraded the system, and in 2003, again APG2 was launched, was published in 2003 after 5 years of this. But here also they continued the tradition of seeking broad circumscription of taxa, broad approach. Like if you want to treat the Avilaceae under Campanulaceae, that's also fine. So same thing also happened here. Like Asparagaceae family, which is quite big family, they included 7 different families, which was again not appreciated by traditional taxonomists. How Asparagaceae should be too big, should not include 7 families. So you should have certain clarity. And then this is APG2. This is number of orders increase. Instead of 40 orders from APG1, APG2 proposed 45 orders. So the number of families broad approach. So it them as a family as an order instead of family. So APG2 recognized 457 families, 5 fewer than APG1. And here, if you see the number of orders has increased from 40 to became 45. Number of increased. And still 55 of the families they got placement. But many of the families they did not get placement. So 55 of the families they got placement. And many of the families they came to be known as again not appreciated. They did not succeed in published article. Here again the broad outline of the system it remained unchanged, but many of the families did not get placement in the earlier system of classification. They got their placement because there was a lot of accumulation of data from different parts working on those families, and they got more data. So the families, the where to be those families to be placed, they got now placement. That's why this was in a much better way. Many families got better placement in this way. And again, the number of orders went up suddenly from 40 to 45. Now it has gone up to 59, the number of orders. And number of families have again reduced. And earlier, if we have seen in APG1, 25 families, they did not get placement. But this 15 families, they got their place and their ancestry was resolved. And now in APG3, only 10 families, they remain unplaced. So this was a better system of classification compared to that, and upgraded system. So there was still a lot of confusion was going on. A lot of people were there registering their problems with the system of classification. So these people were also aware of this, and they conducted an online survey in 2014 asking for their opinion. And many of the people they opposed this bracketed taxa concept. So they said this is not applicable to all families. They said this is not applicable to all families. So with that, they discontinued the use of brackets in APG3. So they had, since also you have placement of more families, so they discontinued the use of bracketed families here. So now they'll be treated as an independent families. In APG3, families, number of families has again reduced, but number of orders has again gone up. And then they have stated after proposing APG3, they propose that note that we do not see the application as continuous for the indefinite future. So they thought at least it's going to be stable for some more time. Even the amount of families in the last 5 years, the changes proposed here are the modest. So there is not much change to overall topology of the tree, but the bracketed taxa concept was removed in APG3 system of classification. And with overall, we continued working with this with accumulation of more and more data. In 2016, again, APG4 was published in the same journal, Botanical Journal of the Linnean Society. And again, the broad outline of the system remain unchanged, significantly reduced. Last APG3 we have seen only 10 families they remain unplaced, but in APG4 number of families also, if you see the overall structure, how it has gone up and how the number of families have gone down and number of order has gone up. APG1 was it was number of order was 40, then it became 45, then 59. APG4 number of orders are 64. And here number of families has come down drastically. It was 462 in one, 457, 415, and here just one increase in one families. Here it has gone little up by 1 family only. So this is the AG structure. Now, what I'm going to show you a simplified version of APG for the students who find APG system most complicated. They don't understand. So here I would like to say you simple version of AG. When I was a student, I used to kind of brain mapping when I have tables like what I do if I have to remember leptotene, zygotene, pachytene, dikinesis, something like that. So I'll just code it DDLJ. So DDLJ, you already know the if I remember a lot. So DDLJ, if you remember, you will remember the only like that. You many people they make that we call this mnemonics. So for this APG4 also I'm going to propose or going to tell you some mnemonics which will help you to understand APG4 in a much better way. So you have to remember this formula. This formula is nothing but you just have to remember ANA, MC, and U dicot. What does it mean? Is you just have to remember this formula called ANA, MC, and U dicot. If you remember this, your whole APG classification you will remember. Let's see this clearly. ANA stands for three different orders. The first A stands for umbrels, nymphaeals, and ostrobellus. Dr. Sandeep, are you there with me?
Yes, sir.
Yeah. So, and then magnolids, MCMC stands for magnolids, chloranthes, monocots, and ceratophyllins. And then you have whole two dicots group here. So this much, if you remember, you can draw whole APG4 by yourself. This much only you have to remember get 5 marks out of 10. Okay, if you are writing more, then you can get 10 marks out of 10. But here, if you just remember this formula, ANA, MC, and U dicot, you're done with APG. And I'm going to explain you further. You just see. And if you see this MC, MC, and U dicot together, if you put them, they're also known as messengerous forms, all four angiosperms. We actually form 99.9% of the angiosperms. So another term for this MC, MC, and U dicot is messengerous forms, means angiosperm which form 9.9% of angiosperm. And remaining one, umbrels, nymphaeals, ostrobellus. If you see this, so they're coming like, therefore, though they're having a monophyletic group, but if you see their common ancestry, here for MCMC dicot, but ANA, there is no common ancestor. It is come appearing as a straight line here. So you can see more clearly here. Can you find out ANA MCMC U dicots here? Just look at this tree. This is nothing but APG4. Or if not,
Yes,
Dr.
sir.
Sandeep, can anyone else help me in finding ANA MCMC U dicot here? Dr. Sandeep, can you
Borrelials is
explain
there.
this?
Yes, sir.
Yeah.
So in we have the basal angiospermic group, that is in case of Anna we have Amborelial, then we have
Yeah,
Nymphaeals, water lily,
nymphaeal and
and then
ostrobus.
we have
Yeah,
Austrorelials, that is Anna.
yeah,
And
that
in
is
case
Anna,
of
right?
MCMC we have Marials and
Yes.
Rails, and
No. First thing, Anna is clear to you, right? Second, leads. This form another M. Then comes chloranthales. It's come appearing as a street line. Means this ancestry was also not properly resolved. So here, sorry, this is monocots, and there is some problem with this slide. But MCMC stands here. So I wanted to show you three leads actually: magnolids, comedolids, monocots, and ceratophyllus. Okay, so this has shifted a little bit. So can you just is it clear to you, Sandeep? Now, Amborals,
yes, sir.
nymphaeals, Ana group, Anastrobelans one group, and then you have MCMC. Like MCMC, M stands for magnolids. Second, C stands for comedolids. Third, M stands for monocots, and then C stands for ceratophyllus. Right? Is it clear to you? Ceratophyllus.
Yes, sir.
So Ana MCMC is clear. Now, can you see this whole U dicot here? Whole grouping, can you see a monophyletic group which is named as U dicot here? Can you see this here? Can you see
Yes,
something
sir.
here? So this whole group combined with a particular feature, morphological feature, the presence of tricolpate type of pollen. And this is named as U dicot group. And in this, can you see some major groupings? It's very important for you to observe. Once you observe this carefully, you will find it. And
Sir,
here, can you find two major
super
asteroids? Yes, yes, yes. So I'm just cutting it down. Now, just if you just see eudicots, all eudicots, here you can find two major groups. One eudicot combined with the morphological feature, presence of tricolpate type of pollen. And you can see this eudicot is appearing here. And in this eudicot, two major groupings are there. The first grouping is called rosids here. Second group is called, and here in rosids also you have a bigger group now because earlier less data was there and this is forming a single monophyletic group. So this they named as a super rosids. Same way here, asteroid also, since earlier asteroid was a smaller group in APG 1 and 2, and then now asteroid got placement of some more orders here. So this they named as a super asteroids. Is it clear to you? So overall, if you
yes,
see,
sir.
this has two major clubbings or two major clades. One clade is called among eudicot, two major groups, super rosids and super asterids. Okay. Now, I want you to ask one question. Can you see this particular lane appearing here as delenials, the one straight line which was left, which is neither falling in super rosids nor going to super asterids? This particular straight line, can you see this? This
Yes,
delineal.
sir.
Yeah. So this delineal, why it is appearing as a straight line? Because its ancestry was not resolved. It could not be placed either in the superorosids or in the superasteroids. Other than this, on the top you can see certain orders called ceratophyllins, ranunculales, proteales, tocodendrils, buxils, and gunnerels. They also did not find their proper placement. They did not form a monophyletic group, so this remained unplaced. So this all other than these five and delineals, if you consider this, but overall what they did to two major group, one major group called super rosids, one major group called super asteroids. superrosives, another is called superabs. This much if you have clarified and you remember that formula, you will understand what is the structure of AG4. So you can see delineal series and ceratophyll and chlorotiers, lepidodendral, buxus, gunei, AG4. So overall structure now, if I again ask you to find MCMCU dipeptide, can you do it? Dr. Sandeep, please help me out.
So
Yeah,
N for
yeah,
A as well,
yes,
M for magnolids,
yes.
and
And you
M
have
for
then,
C for commelinids,
yeah,
then again M for monocots, and
huh.
the last
That's
C
fine.
is one is
Of before clear nowadays. If you just consider ANA group there, they that include 183 taxa, and all the other group, if you consider that actually comprise of 1,09,000 taxa. On this form, all messenger group, this form, this all together you can messengers from 99. And what we know about colony or their ancestry till now is around 2,95,781. Now till now till now 183 taxa where they are to be placed properly. So these three groups, in short, they and this is a very big group. There you have a lot many species, including Nymphia, and then another one you have Elysium. Elysium griffithii, what we call or the star anise fruit. That's the first group. This is very small proportion of just diversity. We have lot of we know about nymphials and nostrovils in much better way compared to Umbella, because in Umbella still we don't have any fossil record available. Nymphias and other group we have fossil data available, but for Umbrella we still don't have any fossil data. That's why we are not able to conclude anything. So if you see the distribution also, they are widely distributed throughout the spheres, let's of the world, and they comprise of three families called Ostrobelacea, Stridenteraceae, Primanes. But everywhere else it is a monotypic group where you have one genus and one species only, and they're restricted to this small part of the world called Eucalidonia. One genus, one species, and they're a very unique group of plants. So this was the overall structure, and just going little deep into
सर
this
एपीजी
ANA
सिस्टम
grouping.
अच्छा है एपीजी क्लासिफिकेशन आप लोगों को है रेडी दो दिन हाँ 2 दिन कल हर्बेरियम का
Sorry,
बताया आज ये इसका जनरल
hello, sorry,
क्लाइमेट
hello. I'm not getting you. Yeah. So okay. Let me conclude, and then you can ask questions. I will give you some time question. So this system, it will help you to think further about the evolution of these groups. And I have what I have shown you the embryo type of Umbrellus group, Eudicots and Nellis group, and Neutrials and Ostrus group. So you already know at this level the S cells you have. So this is the presence of two nuclei here, two synergids here, two synergids here, one XL, antipodal cells have cell in Nuferous Isender type of. So there is one paper by Friedman and Ryerson, which was published in 2009. They tried to understand how they could have evolved. So looking at these, can you just let me know that how they could have evolved, which could be considered as what is in your opinion? Still, it is a hypothesis and still a lot of discussion is going on. So based on these embryo structure, can you tell me something about their evolution? Or maybe I can hear Dr. Sandeep clearly. Can you just tell me like which appears to you as the most primitive one and which appears to you as the most advanced one?
Sir,
Nucleus is a
if
Yeah,
we consider as a progressive evolution,
yeah,
then we think that nymphals and austrobelials might be more primitive in comparison to amborellales.
yeah,
But if we see retrogressive evolution be considered, then in that case, seem to be more primitive than
yeah.
nymphals and
Uh,
austrobelials.
so the same way, you're correct, and lot of hypotheses have been proposed, and still it's a point of discussion because we don't have enough data to say it. But one theory was proposing this nucleoside drive. This is or nucleate is the synapomorphic or ground bias form. This was considered as a basal to all these, and later 8-celled evolved amborella. You see, this is just independent as an independent lineage. It has evolved. And the polygonum type, which is 7-cell type, 8 nuclear type, is a synapomorphy for the clade, including all living angiosperm. And going further, this they saying that the for the Scizendra type, that is the building block. This is the hypothesis, simple hypothesis. Maybe you can put forth your opinion also, and it has not been widely accepted. But in this paper, they have proposed like this, and then they are saying polygonum type embryosac might have evolved from the Scizendra type. So it is going like multiplied here, and then it has been given to polygonum type. So given rise to this polygonum type, and this amborella type. This particular amborella, this is a kind of independent amborella. Was this paper? The authors just found to have a full self-owned embryo sac. Rather, it has an
hello.
8-celled, 9-nucleate embryo sac, which looks like a polygonum type embryo sac. Which one is with one additional synergy? Right. So this is what I've shown you is just a kind of hypothesis, but there's a lot of papers are there. If you Google it, and then you will find a lot of hypotheses have been proposed. So this is what, just to provoke your thoughts, I have shown you the Friedman and Ryerson's paper so that you will think more about how the evolution could have taken place. You can also do more research. You can put forth your opinion in the future, but this is what was proposed in Ryerson and Friedman's paper I have shown you. But things are still moving. People are collecting still lot of data. I think in 2021, 3 years back, many people from China, they proposed a new system of classification. Means it's kind of supportive system of classification to APG. And in 2021, they came up with again a system. It was a kind of supportive. They proposed this. They generated the same tree, but it was based on all plastome data set, like whole chloroplast genome. They sequenced and putting all the representation of the plastomes of all the families or genera, and they came up with a system here in 2021. Here they included 80 genes from 4,792 chloroplast genomes, and there they sequenced 4,660 species in 2024 genera, and then they proposed, and when they saw the topology of the tree, it was not much different from which was proposed in APG4. So many people, they started telling, okay, this is just based on whole chloroplast genome, so maybe picture will change when you propose the system based on nuclear genome, because we already know there are three different genome: mitochondrial genome, chloroplast genome, nuclear genome. So it was independently done just for chloroplast genome. So still criticism was there from people saying, okay, this is based on chloroplast genome. Picture will change if you just see this based on whole nuclear genome. Recently, I think in 2024, 30 January, this paper was published. And here, somebody again from China, they did again, this was based on whole chloroplast, whole nuclear genome. And here they have published this nuclear phylogenetic phylogenomics of angiosperm and insights into their relationship. And surprisingly, you will see the basic structure also did not change. So this concept that ANA, MC, MCU diagonal cells, rosette still stand as a particular group, particular clade, and asteroid still stand as a particular group. So now the question is which part 2 is coming? Like APG5 on the way? Why? What do you think? Whether APG5 will be there with us? So what I believe in the meantime, development since 2016, there's a lot of people still working from different parts of the world. In the meantime, there is one new family was described, which was not included in APG4, like this family under brassicales called Tiganophytaceae. Another family called Petalaceae in Santalils, it was also described. And then there are so many placements have changed during all these 7 8 years. So we go down, and during last IBC also they had announced that APG5 is already almost complete. It probably till December they are going to publish this APG5 as well, which has not changed much. As Dr. Saltis was proposing this, and also the APG6 still there. Only thing they have already got placement there in APG5. So with this, again, I would like to say, Dr. Sandeep, if you're there or other people, can you find out Anna MC here still? Will it be this? Yeah. Is it easier for you to find out?
Last speaker is Anna.
Yeah. Okay. So now at least you have to find out, okay, I can recognize Anna is there, then M is there, C is there, M and C is there, still maybe for this one you will definitely assure you. Okay, so but you still remember there's some take home message there from my side. First thing, molecular phylogeny is considered to be a dynamic system. It is continuously evolving. It's not like once you do something, it is final, it is done. No, it is with more accumulation of data from all parts of the world. Techniques are advancing day by day. So it is a dynamic system, still evolving. And but molecular systematics also have certain limitations. Also have certain limitations. Still, we are not able to resolve also certain limitation. And there's very famous quote by Stevens. I have just marked here for your reference. He has written here our morphological, anatomical, and chemical knowledge of many critical taxa is woefully incomplete and must seek expansion. Perhaps unfashionable work must be undertaken to verify the distribution of morphological, anatomical, and chemical factors. So if you are even sitting in a very small college doing some small work, remember you are still contributing a lot to science. If you are thinking you are simply working on some or say revision of some small group, or say revision of some small group. So just always remember if you are doing some small revision work, remember you are still contributing a lot to science. So don't be considered as unfashionable, but still contribute a lot of science. Whatever you're doing, keep on doing. They're much more advanced than you. So even if you're doing some small revisionary work, that is also a contribution. So don't be considered as unfashionable, but still contributing a lot to science. So remember this by so it has also combined molecular data with the new morphological data for understanding the evolution of angiosperm biodiversity. With this, I'm going to conclude, but before concluding, how much you understood, I would like to understand that. So if some students are there, I have certain questions for you. So first question is like this. So which of the following clade is not recognized as APG ecosystem? Whether it's magnolic, bromeliad, aspire. What is your answer?
Okay. Now, it is open to this.
Hello?
Anybody?
Hello?
You
Hello?
respond for it.
Yeah. I'm waiting for your answer. What could be
The
the answer? Dr.
dicotyledon.
Okay, Dr. Sandeep think dicots would be the answer. Answer D is correct. Do you agree with Dr. Sandeep? Okay, so let's ask Okay, so let's ask kind of to there were two groups into eudicots and you have basal dicots. So, and monocot was within that. So dicot would be the correct answer. The second question is, what is a primary criticism of the APG system of classification? So since I'm not able to hear from others, maybe I'm going to ask again Sadnif to clarify the first thing. What is the primary criticism of the APG system of classification? First thing, lack of consideration for traditional morphological characteristic, overemphasis on molecular data, neglecting other forms of evidence, inability to account for hybridization events among plant species, or all of the above. What could be the correct answer, the most apt answer for this? What do you think? Dr. Sandeep, are you there?
Yes,
Uh,
sir. Sir, I guess maybe a lack of consideration of for a traditional morphological character.
okay, so your guesses are there, but the correct answer is D. All of them they're considered as a criticism for APG system classification because they also never considered this hybridization event or they overemphasize on a molecular data. So other form of evidence were not considered at in entirety. It was not considered, but of course, answer A is also included there. The next question is, according to APG system, which of the following is not a major clade of the flowering plants? Magnolias, eudicots, monodicot, monocots, and gymnosperms.
Sir,
Gymnosperms?
gymno.
Okay, gymnosperm is the correct answer. Yes, it was not considered a major clade of flowering plants. And then the last question would be probably the APG system utilizes which of the following techniques to construct taxonomy?
Cladistics.
Whether it's cladistics, lenient taxonomy, classical taxonomy, or traditional classification. The answer is cladistics.
Statistics.
Correct answer. Yeah, that's the correct answer. The last one will be this one. APG4 system recognizes a group of basal angiosperms called lilies, magnolids, monocots, or basal rosids. Basal angiosperm. Remember this. So there you have
Magno.
eudicots and then you have
Sir, Magno
okay,
leads.
let's see. Yeah, that is correct answer. With and one more, sorry. The APG system classification is considered more dynamic compared to systems because it incorporates fossil evidence extensively, is based solely on morphological characters. It allows for frequent updates based on new molecular data, and it follows a strict linear hierarchy.
C. C allows for frequent updates based on new molecular.
Let's see. Yeah, that is the correct answer. And with this, I would like to thank everyone, including my director at ARI and also to the organizers, Dr. Nagaraju and everyone at Government College Hyderabad, including Dr. A. Mao and all my friends from Botanical Survey of India. Thank you so much for giving me this chance. I'm just concluding my lecture here. I hope you have enjoyed it. With this, I'm concluding and I'm just going to
So thank you very much, sir, for giving elaborated talk, sir. We are very feel happy, sir. You have given very advanced way of the taxonomy. Now, what the most of the countries are following, we also need to follow the APG4 system, and that even APG5 system also going to exist in the within the short span of the time. That we now in the college level only following up to the APG2 only. We also have to upgrade it of APG4, APG3 at least. Most of the people are got the most advanced knowledge with your valuable talk, sir, because this advanced talk we couldn't find in another way in another area other than you, sir. We feel you are the one of the best and most expert in this system of classification in advanced things. We feel very proud of you, sir. Given elaborated talk, enlightened so many people about the APG system of classification, advanced system of classification. Usually we are following Bentham and Hooker, Engler and Prunter, but also, hello, sir, is it audible, sir? Sir, is it audible to all?
Yes, sir, audible.
Yes,
Yes,
yes.
sir. Yes, sir.
Yeah, yeah. Yeah, okay, okay, okay. I'm very feel happy, sir, because of your valuable presence. Because of your valuable presence, we got the good knowledge. We acquired the most advanced knowledge. With this, on behalf of our Department of Botany, Government City College, on behalf of all the participants of this national level workshop from the different colleges, teaching faculty and the students, they got elaborated knowledge. I think it is a very good lecture of this among the national workshop. We feel proud of you, sir. We all very much
Sorry, somehow I got
thankful to you, sir.
disconnected. Yeah, I hope the message is clear.
Oh, sir.
Somehow I got disconnected.
Sir.
Yeah, yeah.
Sir,
So
sir.
this
Okay,
the
sir.
question answer session was
We are
okay.
very fit. Yes.
So if
No,
you
question
still
session
have
already.
somebody has
We
a
are
question.
there.
Okay. So in case somebody has a question, I'll be happy to answer.
I have one question, sir.
Somehow
I
it
have
is.
one question.
No, no. Okay.
Yeah, yeah,
Sir,
Who is that? Okay, you can.
yeah, I would like to know, sir,
yeah.
that they have taken some plastidial markers and nuclear markers. So,
Yeah.
did they take some mitochondrial markers as well?
No, they did not take because that did not give good solution. As you know, they have different rates. So then already we know that is established fact that micro because of the different rates of evolution, mitochondria is not considered for phylogenetic reconstruction. So this was not considered. Till date, we don't consider mitochondrial regions for constructing a phylogenetic tree. So it was not
Okay.
considered.
Anyone else?
So, more question, the basal group can it be considered the most primitive, or what is the exact definition of basal?
No. Still, it is not. You cannot answer unless you have fossil data for everything. What we understand till now, because it is very close, the characters going very close to gymnosperm. You can tell maybe they are primitive. They are appearing primitive, but still now there is no definitive answer.
Sir,
People still know.
sir, in that case, sir, in Ventresi, we don't have any vessels in the xylem.
Yeah, correct. So as per like in gymnosperm, if you see now, it shows toward the kind of tendency towards that. So that's why there's no definitive answer still.
So, I mean, I want to ask that the vessels of the Ventresi, is it a ancestral character, or is somewhere I have heard it is a derived character? So, what does it mean?
Yeah, derived means with evolution, if you have appearance of certain new character, that is called apomorphy or the derived character. And if you have some previous character, the parental character is called plesiomorphy. So apomorphy and plesiomorphy, you have these two words. Apomorphy for the derived one and plesiomorphy for the primitive character, the parental character.
Thank you, sir.
Okay, yeah.
Okay. Anyone else?
Yes, sir.
Good
Yeah,
afternoon,
yeah.
sir. Sir, I
Good
wanted to ask
afternoon.
a
Yeah,
question, sir.
yeah, yeah.
Which classification we have to follow for the identification of families, sir? For identifying the families in the practical sessions for students.
See, it's when we have to identify at the family level, APG does not propose something which you can identify is up to a family member. Family structure is still same, which was there in the Bentham and Hooker. When you go up to family level, APG does not propose something which is so never talks about identification of plant. It is how they're arranged. So definitely, if you're going to identify a plant, so placement, if you're something is going as per Bentham and Hooker system classification, if it is going to sterculiaceae, so better you don't say sterculiaceae, you say it is malvaceae. Because as per APG4, it is now a monophyletic group, so you don't treat your plant sterculia under sterculiaceae, you treat it under malvaceae because that is the most advanced system of classification. But identification, you still have to follow the floras or revisionary work on. Okay, am I
Okay.
clear? Yeah,
Thank you.
Yes, sir. Yes, sir.
Yeah.
yeah,
Thank you,
yeah,
sir.
Yeah.
Thank
Yes. Anyone else?
Yes, sir.
Sir,
Yes,
one
sir.
more question, please.
yes,
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 sir.
yes, sure.
Oh,
Sir,
oh, very
sir, I wanted
enthusiastic,
to
very
know that,
active. Good.
I mean,
I'm happy. At least people have got
what,
some enthusiasm about it. Yeah, yeah.
sir,
Yes. Yes,
why I want to get to phylum? I mean, why it has been left out, ceratophyllum?
Because maybe first the DNA data, no? So why it was left? It is just based on mostly DNA data. So if the number of sequences what you are using to construct a phylogenetic tree, if there are certain variations compared to the closely aligned, definitely it will show as a distinct lineage. So this all because of DNA variations. Nothing like, because it's all generated, the trees are generated by the software, by the algorithm. So since algorithm will see with the comparative that this particular lineage you have four nucleotide differences, it will treat differently then. And when you go back to the taxonomic level, like when you see the morphological characters are also, they're corroborating with the result which you have got using nuclear data or the plastidial data. It is also matching like that. If you compare other groups also, it is matching like that. So that's why ceratophiles. It's all about the molecular data first, and then if you go back to the morphological data, it is also supporting that. That's why.
So last, if I get opportunity, I want to ask just last question, sir.
Yeah.
That
Yeah.
normally, I mean, in papers we read that the land plants has their ancestry from the I mean the members of carels, I mean carophyceae.
Algae,
That is from
exactly. Yeah.
aquatic to land. That is the terrestrialization happened. So in that
Mhm.
case, sir, some of the angiosperms are in water, and some of the
Mhm.
angiosperms are land. So which one we
Mhm.
will consider to be primitive?
No, no, of course, algae are primitive. If from algae has gone up to it's taken a long journey. So you cannot just based on habitat, you can consider that whether that is primitive or that is. So definitely algae, because of if you see the organogenesis, that has taken a long time. So from algae, then you have bryophytes, and then you have pteridophytes, then you have angiosperms, engine. So you cannot compare angiosperms along with algae. They are much primitive from angiosperms.
Because sir, ceratophyllum means is found in water, generally in
Yeah, 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 that is there, but you can say, but it is showing other angiosperms as well. So you cannot treat this as algae.
Thank you, sir.
Okay. And there's already, and that I have already discussed about the convergent evolution that could happen. Like if you see this birds and presence of beings in bird and bat, you cannot treat both of them as a mammal, right? Or the birds. You have some algae characters, algae features in ceratophyllins, but you cannot treat angiosperm ceratophyllins as angiosperm because those characters are maybe as a result of convergent evolution that is appearing there.
You, sir.
Okay, yeah, yeah. Yeah, Urvish, you have some question.
Yes,
Yeah,
yes, sir. I'm Urvesh Patel from Gujarat. I have a very,
yeah,
very basic question that majority of the area of universities are following just like Bentham and types of systems. So how we
yeah.
can link this from, we can start the advances to those students
Mhm.
who are just try to following these types of systems.
Of course, don't ignore Bentham and Hooper system classification. That is also good when we consider morphology at morphology level, and when you go to the field, that is also even for me that is very much helpful. So don't simply ignore that. People should also know that the student should also know about Bentham and Hooper systems classification. But you have to update yourself. What is happening in the world, other part of the world, what advancement are taking place, and how now we have started classifying the things that you should also teach your student. So that way APG 5 or 4 definitely you are going to teach them. So it was not like the way Bentham and Hooper proposed. It was just based on morphology based taxonomy. But when we check the DNA, it is saying that it has to be divided. That's why you have to teach APG as well as Bentham and Hooper, both to them. Yeah.
Okay,
And
and
then Vijay Lakshmi, I think, yeah. Vijay
yeah,
Lakshmi,
so can you suggest some for basic references or some softwares which are useful in APG for classification understandings?
no, not for APG. I can suggest you there's already a website dedicated for a APG system from Q, and you can refer to that. All the information which I've shown you already given. You can simply refer to that website. important.
Thank you. Thank you so much, sir.
Yeah, yeah, yeah. Vijay Lakshmi, you raised your hand. You have any question? Okay. Okay. Hardesh Singh, you have any question? Okay. So anyway, I have given you my email ID in case if you have still hesitation in asking me question. I'm just typing my email ID again. So you can drop me a mail there, rkchaudhary@aripune.org. You can send your questions here. I'll be happy to answer you. And Dr. Sudhakar Reddy sir is also waiting for his talk, so I don't want to take his time. So sorry sir for taking more time. It's nice to see you after a long time.
I think my presentation is not required.
So it was supposed to be, I think, start from. So
Yeah.
it's okay, sir. You can take over now. So
Thank you very much.
yes, thank you. Thank you. So I can leave the meeting, right, Nagaraju sir? So I'll leave the meeting. So you can go ahead with Dr. Sudhakar Reddy sir. Thank you for your presence.
Sir, we are very much thank you, sir. Thank you. We feel proud of you, sir. We are given very elaborate and advanced technology, advanced in the taxonomy, especially in the APG system of classification. That we feel proud, sir. You are given an advanced up to APG 4. Now, upcoming APG 5 also you are given introduction. Yeah, the most not only the morphological, mostly based on all the molecular techniques and new advanced techniques, phylogeny, all the things which are very useful in the taxonomy. How best we can identify the species level, how it will be useful to clarify the so many doubts in the taxonomy. That's that's we feel proud of you, sir. We are very happy, sir. We are very much thankful to you, sir. We are my heartfelt thank you to you, sir, for accepting to give the
No.
talk. We are very wholeheartedly thankful to you, sir. Thank you very much, sir, for giving. I will talk to you, sir, after this. I will talk to you,
Yes,
sir.
yes,
Please,
yes, sure,
this
sure,
section.
sure, sure,
Yes,
sure.
sir.
Yeah. So I'll
Thank.
leave the meeting. Thank you all. Yeah.
Yeah. Whatever the technicals, I will do it, sir.
Yes,
Thank you very much, sir.
thank you.
Thank you. Sorry for the inconvenience, sir. Due to technical issues, some of the it has happened. That for that we felt
No, it's
sorry,
okay.
sir.
Yeah,
That's my
yeah, yeah,
mistake.
yeah, yeah.
Yes, sir.
Okay,
Sir.
sure. But leave this
Yes, sir.
part.
Thank you. Thank you very much, sir. Thank you for giving this opportunity. Given a chance to the people who they are participating, the students and faculty. Thank you very much, sir. And now another eminent person, scientist, SC, Dr. C. Sudhakar Reddy, sir, going to deliver a talk on advanced taxonomy. Another advanced taxonomy topic it is advanced taxonomy by using the GIS, GPS for the taxonomical identification and the best ecological classification, ecological studies and forest studies, biodiversity studies, how it will be useful, how it will be mechanized, that all will be given, elaborate by our most beloved scientists of National Remote Sensing Center, ISRO, Balanagar, Hyderabad. He is the very eminent scientist and very highly high indexed topmost in the world-wise topmost world scientist is in the even last from the last 3 years he is in the first and second position in the worldwide scientist topmost reputed topmost high index journals published. We feel very proud of you, sir, for given opportunity to listen your talk, to learn from you. This all we feel very happy, sir. We are very happy to see you, sir. Sir, Sudhakar, sir, you,
Yeah.
sir, yes, sir. So please, you please uh, start, sir, your session, sir. Please, sir. You please share screen.
Good afternoon, Dr. Nagaraju and all the participants. Hope this slide is visible.
Yes, is visible, sir. Visible and audible, sir. Very clear, sir. Thank you, sir. You can start, sir.
Yeah, most welcome. Thank you, Dr. Ritesh Chowdhary, for the excellent presentation and also interacting with all the participants. My subject is towards the geospatial technology and where the technology is going to help the taxonomy for the better scope and for the advancement. So in my presentation, I will be covering the geospatial technology with the innovative tools of the remote sensing, GIS, and GPS. So while studying the biodiversity, our first preference is for the conservation of biodiversity. So while going for the conservation of biodiversity, because the CBD and many other international negotiations and all the global challenges identified, the loss of biodiversity is one of the primary crises for the sustenance of the